Okay. All right. So you see here the simulator. You don't have to worry about. You can click allow all. It's just a cookie thing. You want to start with a smaller sample size. You get to pick how big your sample sizes are. You get to pick up to 200. So your goal is to show that smaller sample sizes result in larger percent errors than larger sample sizes. You can pick whichever coin you want. Okay. I'm gonna go with the US penny because I want to. Actually, no, that's kind of boring. Let's go with the Aussie dollar. We'll go down under. All right, flip the coins. It really doesn't matter what you pick as long as you have a heads or a tail. So we got a tail, head, tail, tail. All right, so I got 1, 2, 3 heads. 3 heads. Okay. So I'll go back, say 3 on Excel. What I could do is say at 0 half-lives, so the half-life number heads. So at 0 half-lives, 10. After 1 half-life, I'm down to 3. All right, so go put this to 3, flip the coins, tail, tail, head. All right, 2 half-lives, I'm down to 1. Go back, set it to 1, flip. It's a head. Ooh, 3, I'm down to 1. Flip again. Tail, 4, gone, done. That trial's over. You could run it again, starting back at 10. You could say I'm satisfied with my data. Let's go to a bigger sample size. Let's try 100. Flip them. You got a little bit of counting to do. But here's the thing. It's a lot faster to use the simulator because normally I make people do it with actual pennies. That's annoying. So that's how you're going to collect the data. You want to make sure you got a plethora of small samples and a plethora of big samples, so you can go ahead and show clearly that to target purpose 1, evidence that larger sample sizes experience a smaller percent error. In the process of doing this, you're probably going to see that the smaller sample sizes sometimes just boom, nail, 50-50 split right on the dot. The larger sample sizes, it might happen, it's pretty rare. So the question was, after the first initial flip, how do I determine how many coins I have? All right, so let's say, go to 10, flip, 1, 2, 3, 4, 5, 6 heads. So when I go back, there were 6 heads. So I had 6 coins survive the first half-life, then flip again. So we'll go here. To watch the video, that's actually what I'm recording now. One thing I want to point out on your data tables, make sure you start with half-life number 0 with however many coins. So if you look here, I started with 0 half-lives and 10 heads. When you do the graph, we want to do a scatter plot and insert your best fit line. You already know what shape the best fit line should be. I've said it multiple times. The questions here, number 1 is hitting right on purpose number 1. Provide me the evidence and explain how it works. 2, you're hitting right on purpose 2. And 1 sentence, describe the type of function. Number 3, provide select evidence from your data that shows each half-life is unique and independent from the previous half-lives. So let's kind of look at this data here. My prediction on this would be after 0 half-lives, I would have 10. Then I would predict I would have exactly 5. Then I would have 2 or 3. Then I would have, 1 or 2, right? So when I immediately went down to only 3 left after half-life number 1. A better way to say this, let's say your prediction is 0, 1, 2. I start with 1,000 coins. I predict 500. I predict 250. Fair? Let's say in actuality, start with 1,000, but after 1, something really weird happens and you end up with 520 heads. Okay? If you're a gambling kind of person and you know after 1 half-life there's 520 coins, are you still gonna predict 250 left after 2 half-lives? Or would you like to change your answer? That's what question 3 is hitting on. Knowing what the result is of the first half-life, does that change what you predict after half-life number 2? And does the mathematics support that? That increases the randomness of what's happening, by the way. 4, it's a discussion. Is it possible to determine that any specific coin when it will or will not decay? The answer is actually no, it's not. So you need to discuss why you cannot make that prediction. And number 5 is just a question somewhat related to the lab, but kind of hitting onto the smaller sample sizes. Carbon-14's half-life is given, dinosaurs 65 million years ago. Why is carbon-14 not viable? Rubric is here. If it loads, standing circle, there we go. Rubric is here. Make sure you check everything off on the rubric. 50 points, standard. And submission via email to your entire group should be CC'd on it, due Friday, May 21st, 2021 at 11:59 p.m.